Welcome to the screencast for the demonstration of chi-square test on spaces. Don't forget that in our previous class, we stated that chi-square test, to be able to use chi-square test, it means you have both your dependent and independent variable to be, you can see it's both your dependent and independent variable to be categorical variable. They are both categorized. They are not continuous in any way. None of them ask for a continuous variable. Invariably, it simply means, if we are to give an example, it simply means from the data we worked on. Let me open our data that we've worked on in the previous video. Now, this is the data. We have a categorical variable. You have a categorical variable here, that's Coke, Fanta, and water. And we should have another categorical variable for us to be able to look at association. This time around, it's not difference in mean, it's check for association. It should check for association in terms of chi-square. Chi-square simply means you are going to be needing to check for association between two variables, that's the dependent and independent group. Now, let's take for example. Now, let's see. We want to categorize glucose level now, because there are ways where we can convert this our continuous variable to a categorized variable. The first thing we need to do is to have a benchmark. To have a benchmark of glucose. At what level does this become another category? But for glucose, for example, glucose level will fall into another category when it has a value, for example, greater than 7 milligram per dl. Anybody that has a value of 7 milligram per dl is most likely hyperglycemic. Anybody that has a value lower than 3 milligram per dl, for example, is hypoglycemic. However, anybody that has between 3 and 7 is normoglycemic. So now let's do that and see. So it means we are going to go to our variable view and we are going to make another glucose category. We are going to name it gluc underscore. Remember, this place only accepts underscore. Gluc underscore category. So let's just gluc, yes, underscore cat. So let us now assign values to it. Now, let's say the first category, which is 1, we will represent hypoglycemic, those who have lower than 3 milligram per dl. We call it hypoglycemic. I'm teaching this because sometimes you may need to convert your continuous variable to a categorical variable. This is how to do it. The first thing you need to do is what? To get benchmarks for your continuous variable. At what point will that your continuous variable be in another category? Like in the case of this glucose, anybody that has less than 3 milligram per dl, for example, has hypoglycemic. So we now state it here that it is less than 3 milligram per dl. Close on brackets. Let's add it. Now the second group are those who have normal glycemic level. We call it normal glycemic. And if they are normal glycemic, it simply means they have value between 3 to 7. Let's add. The third one are those who have greater than 7 milligram per dl, and they are called hyperglycemic. It seems invariably they have greater than 7 milligram per DL. These are fictitious data. They are assumed data. They are not really real data, but we are just using it for the purpose of learning. Maybe I did this to milligram. And we are true. Okay. Now let's go back to our main data. So we now start inputting 3. I have to change this. So 3 is under category of normoglycemic. Normoglycemic is 2. Let's first by clicking all the normoglycemic. Normoglycemic, yes, another normoglycemic. This is another one. This is another one. We state that only greater than. So this is, and that is all. Those are the 3 normoglycemic. However, we can just check. Okay, this is another normoglycemic. 6 is a normoglycemic. 7 is also normoglycemic. I think that's all. Now, what about hypoglycemia? Hypo. Do we have any hypo? Do we have any hypo? Yes, we have 1. 1 is for hypoglycemia from our coding. This is another one. This is another one. This is another one. Now let's check for. This is another hypoglycemia. Now, what about hyper? Hyper is labeled with 3, and this is hyper. This is hyper. 12 is also hyper. 13 is hyper. 13 is hyper. 4 is normal. So now we are done. We are done with so invariably we've converted this glucose, just in case we have that kind of case or scenario. You convert this glucose continuous variable towards a categorical variable, which we've done. Now let's analyze for chi-square. Now before we analyze, the first thing we do is to state our null hypothesis. And our null hypothesis we go as does. We say that our glucose category, which is the dependent variable, is not associated with whether you are taking any type of drink, whether it is local, whether it is Coke, Fanta, or water. The change or category of glucose is not associated with the group. And what is the group? The group are those who take different soda, including water. So there's no association between you taking Coke, Fanta, or water and the level of your glucose. Now let's now check it statistically. Now we go to analyze. For chi-square, we go to analyze. We click on descriptive. And we go to cross tab. Click it. The next thing to do is you can do it in any way. You can make your row, you can put your categorical variable in your row and the other one in your column or otherwise. However, for the purpose of this class, I'll put glucose category in our row and I will put I can't put this continuous variable, so I have to put the groups in the column. Now the next thing to do is to check your statistics and click on chi-square. Hit on OK. Now the next thing we are going to do is to hit OK. Now this is the value. This is the calculation. Now the first thing we do is you can see the grouping, the cross tabulation. It's group, Coke, Fanta, water, and then the next thing to do is to check the significant value. These are the significant value. Now the first thing, we have 3 here. If you observe, different significant value. However, it's because you need to obey some assumptions in SPSS. The first thing you do is that you check this percentage here. If the percentage is more than 20%, then you go for this Pearson's chi-square. You go for Pearson's chi-square. But if it is lower than 20%, then you go for likelihood ratio. You go for likelihood ratio. But for the purpose of this class, it is greater than 20%. So we now go for our Pearson's chi-square, which states 0.02. And 0.02 is quite significant, and it is smaller than even the benchmark of 0.05. So we can say what? That there is an association. So, and if we are saying that there is an association, there is no negation in that statement. It simply means that we are going to reject our null hypothesis. It means hypoglycemia, normoglycemia, or hyperglycemia is dependent on whether you take any of these drinks. They are all dependent. It simply means that majority of those who are hypoglycemia took water. You can see that they took water. Look at hypoglycemia. We have 0 in Fanta, 0 in water, in Coke, sorry, and we now have 5 in Fanta. So basically, it's evidence. This is evidence-based statistics. Those who took water had low, you can see, they had low normoglycemia because there's no glucose in it, and they are not hypoglycemia. They are not hypoglycemia. Now, for those who took Coke, majority of them were normoglycemic, and only one of them was hypoglycemic, was hyperglycemia. But for Fanta, 2 of them were normoglycemic, but most of them were hyperglycemia. And that is the reason why in our previous non-parametric tests, statistically, Fanta had more glucose level than water. And you can see it is evidence here in the chi-square as well. So basically, this distribution is statistically correct. And we say that there is an association between you taking glucose, and there's an association between your glucose category and the type of fluid you've taken, either Coke, Fanta, or water. I think that is how chi-square runs. However, I will want to give one more example with our, I'll give one more example with our previous data that was gotten from our pretest. And this is the data. Now I want to check the association between grade and gender. You can see from here, I want to check if the fact or the basis of you scoring a very good grade is dependent on whether you are a male or female. How do we do it? Now let's go analyze descriptive statistics. You click on crosstab. Now hit on gender. It can be on anyone, whether the row or column for this case, and grade. Then we hit on statistics, then chi-square, then we click on OK, then click on OK. Now this is it. This is the output. This is the output. Now, from this output, you can see that it is plotting gender on grade. Now, statistically, is it different? You can see this is, first thing you check is this up to 20%? Yes, it is more than 20%, so we are checking Pearson's chi-square. Now, for Pearson's chi-square, you can see that it is not significant. It means gender does not determine which grade you are scoring. In this case, does not determine which grade you are scoring. So, this is the end of the fifth session, and we are through with parametric and non-parametric analysis. I hope find this interesting. For any information or any situation where you don't understand anything, you can ask questions or refer back to the previous videos. Thank you very much.